Welcome to Bravel Institute. Today we are discussing about Martingale. So initially I'll start with the Martingale strategy in betting system. Then we'll move to the Martingale stochastic process. Martingale strategy in betting system, they say doubling your losing bets until you win. So once you lost your bet, you have to make a double amount for next betting. How to do, we'll do one example, we'll understand. This is one betting system. There is a head and a tail. So here there is a 50% of chance for win head and 50% of chance for win tail. Whoever is going to casino and all will understand this betting systems and all. So we'll check what is the result, and we are going to bet some amount whether it is a gain or loss. So first I selected in head $1. So amount $1 is kept in the place of head. If I win the toss, I will get $1. If I win the toss, it is a head, then means I will get $1. But unfortunately, I lost my betting. It was a tail, so I lost my betting. So my loss was $1. So as per Martingale strategy, once you lost your bet, you have to make a double amount. So I make a double amount for 2. So my value I change it to 2. Just check the result. Result was again tail. I lost again $2. I doubled my amount again. Next bet I put a $4. Here it is $4. Again the result was tail. So I lost again $4. I am really unlucky person. First 3 tails also it was a tail. Again I increased my amount. I doubled my amount to $8. We just check it. So whenever I lost, I doubled the amount from 1 to 2, 2 to 4, 4 to 8. Again I lost the bet. I lost the -8. So what is my cumulative loss? Just to check, $15. I lost $15. So again I doubled my amount. It was a 16. Day is not good. I lost first 4. Betting was a tail. You just check, it was a head. I win the bet. So I received $16. So my winning is $16. So what is my total my gain was $1. So in this strategy is telling, once you losing your bet, you make a double amount until you win. So here I win the betting, so I received $1. Total loss was $15. Then my gain was 16. I received $1. I can't say this is a winning strategy in betting system, but I can say one thing: if you fail in life, double your efforts. Double your efforts. Once you fail in your exam in first attempt, you make a double efforts to pass the exam. Not only exam, whatever situation, any challenges, once you fail here, you make your double efforts here. You must win, otherwise you make again double efforts. You must win in here or here. So this is just a small example of Martingale strategy. We'll move to the Martingale stochastic process. Just what is a Martingale stochastic process is expected future. Expected future is equal to current value. So expected future value is equal to current value. Simple idea. So we are expecting our future value that is same as the current value. Sometimes it will be optimal value or best estimation of the future value. Current value will be a best value, maybe best estimation for the future value. So according to Martingale, this expected future value is same as the current value. We'll see one example, we'll understand. In 2017, my friend started one company and his sales was 100 million. And 2018, sales was 110 million. And 2019, it was 15 million. And 2020, it was 120 million. And 2021, it was 125 million. Now this is my current year. Here it is my current year. And I am going to expect 2022, what is my business. So if it is a 125, I expecting it is the same 125. As per the Martingale, I expected current value same as the future value. In 2023 also, my expectation is same 125 only. So how to generalize this one? We can say it is a y1, y2, y3, y4, y5. This one is y6, y7. This is my expectation. So my current value is y5. This is my future value. It is same as the future value. So generally I can write expectation of what I am expecting for y6, given that y1, y2, y3, y4, y5, it is a y5. I expected my future value, it was a 125 million. In current year, it was a 125 million. I expected my future value, it is a same as current value, 125 million. So expectation of the y6 based on this all data. Based on this all data. From y1 to y5, based on this all data, we know this all data. I expected my future value, it is same as the current value. I know y1, y2, y3, y4 and y5. So I expected my future value is equal to 5. In general case, I can write expectation of future is n plus 1. Given that y1 to up to yn, we know these all values. y1 to yn, we know the all values. So this is equal to yn. So expectation of yn plus 1, y1 to up to yn, we know the values, it's equal to yn. This is in a discrete case. In continuous case, how to write in continuous case? We can say ST is a stochastic process. ST is a stochastic process. ST is stochastic process. Expectation of ST, given that EFS is equal to SS. We'll see what is the ST, SS. So here is S1, you can say it's a S2, S3, S4, S5. You can say it is a SS. So my current value is SS. I am going to analyze my future value. ST, this is ST plus 1, this is also same as 125. So my expectation is from expecting ST, given that FS, what is the meaning of FS? FS is a filtration. F stands for filtration. What is the meaning of filtration? We know all the values from S1 to up to SS. So this S1, S2, S3, S4 up to SS, we know all the values, including the time S. Now the current time is SS. This S is the current time, including the time S. We know all the values, and we are going to expect the future value. We are going to expect a future value with knowing all the values from 1 to S. This all time from 1 to S, we know all the values. That is why you can say ST is adapted to FS. ST is adapted to FS, then expectation of ST is equal to HS. We expected the 125, same as HS. So this is one condition. In continuous case, this is one condition. Another one is one more condition. This should be a S less than or equal to T. This is a first condition. S should be less than or equal to T. Expectation of EST less than infinite. Should be less than infinite all time, all T. So Martingale, there is two conditions. Whenever doing the problem, solving the problem, we have to use this formula. Most of the case we will use this formula to solve our problems, whether it is a Martingale or not. So expectation of EST given that FS is equal to SS. So this filtration is used. Why filtration is used? We know all the values from 1 to S. We know all the values, including this time also. In this time also we know the values. This is over. We know these values. Then future value is equal to SS. And this ST should be less than infinite. So this is the Martingale, and two features is there. Two features also will explain. When my time is EST, in this time my business was 120. I expected my EST given all the values of FS. We know all the values from starting to up to S. It is less than or equal to SS. You see, when I expected my expected value is 120, it is less than my current value. This was my current value, but my expected value is 120 is less than the current value. This case we can say it is a super Martingale. In this case we can say it is a super Martingale. What is the reason in super Martingales? Maybe negative drift. Some negative effects is happen for the sales. The sale is decreased. So my sales was expecting 120. Maybe some other reason. So due to negative drift, my expectation is decreased from less than the current value. So we can call this one is a super Martingale. When my expectation is ST EFS greater than or equal to SS. So this one is, you see, if it is a 130, you see, my expected value is greater than the current value. We can call this is a sub-Martingale. We can call it is a sub-Martingale. Maybe the reason some positive drift, positive sales, somebody joined in the company, maybe some machinery is purchased, maybe some other positive drift, our current value is increased to the here. So greater than the current value. So we can call it is a sub-Martingale. So this is the Martingale. We learned what is a Martingale, what are the conditions are there. We will check this is a main condition, expectation of EST given that FS is equal to SS. FS is nothing but is a filtration. We just giving from 1 to S, we know the values. That is why we given on conditional expectation. With knowing all the values only, we are expecting ST. So this is equal to current value and what is a sub-martingale and super-martingale. Now we'll solve one problem, we'll understand. WT square minus T. This is one stochastic process. Whether it is martingale or not. You are checking whether it is martingale or not. So WT is a Wiener process. WT is called Wiener process and WT square minus T, we are checking whether it is martingale or not. It is a stochastic process. So what is our martingale condition? So ST, given that all Fs should be less than or equal to SS. So expectation of ST, given that Fs is equal to here. Here he is substituting, instead of ST we are substituting WT square minus. So expectation of WT square minus T, given that in all Fs it's a Wiener process, we putting W in top, it's equal to what will be our output. We'll just check what is our output. It is SS. You have to put it like that. We should get it is a initial process square minus S. We should get it like that. If you are getting WS square minus S, then this process is martingale. We don't know whether it will get or not. So we'll checking for expectation of WT square minus T FSW. So we need WS. So WT we are going to change WS plus WT minus WS. So this WS is the initial current value. We know the current value and WT WS is the increments. We call increments of the Wiener process. So we are splitting WT to WS plus WT minus WS. This we know the values WS and WT minus WS. It is a increments. This WT minus WS is following normal distribution of 0 and T minus S. So mean is equal to 0 and variance is equal to T minus S. These things we have to substitute here. So instead of WT we are substituting WS and WT minus WS. You are just substituting here WS plus WT minus WS all square. All square given that FSW minus T. T is taken out, so minus T. It is a, you just check, it is a plus B all square. It's like a plus B all square. This value is combining or taking, and it is a WS. So how to change expectation of WS square plus 2WS WT minus WS plus WT minus WS all square, all given that FSW minus T. This is our equation. So it is a B, A plus B all square, WS square, we 2WS, WT minus WS, WT minus WS all square. Now what is the value of WS square? This value and this value and this value. Separately we are finding out what is expectation of WS square and expectation of WS into WT minus WS and expectation of WT minus WS. We know the values. Expectation of WS square, given that FSW is splitting the each term, this is equal to WS square. This is the initial value. We know these values already. Already talked this value we knows because it's a current value. We know these values, so it is a constant. So Ws square. Next term is Ws expectation of, how to write, bottom will write expectation of Ws and expectation of 2Ws and expectation of 2 will taking out, and Wt minus Ws, and this value we knows actually it is a mean is equal to 0. So this value is 0. So total this value, what will happen? This value is 0. So total that value we can write as a 0. So expectation of 2Ws Wt minus Ws, this is equal to 0. This value is equal to 0. Next is Wt minus Ws all square. How to find out Wt minus Ws all square? You see, expectation of Wt minus Ws all square. This is same as expectation of S square. Same as expectation of S square. How to write expectation of S square? Expectation of variance of H. Variance of H is equal to expectation of H square minus expectation of H all square. You see, this is a variance. So we just taking out expectation of H square is finding out like that. Just taking out, it is a variance of H plus expectation of H all square is equal to expectation of S square. You see, variance of H, it is a T minus S. So this is equal to T minus S. Variance of S is equal to T minus S. Expectation of H is 0. It is a, we have to substitute this value, expectation of Wt minus Ws. Wt minus Ws will write like that. Variance of Wt minus Ws plus expectation of Wt minus Ws all square is equal to expectation of Wt minus Ws all square. So see, variance of Wt minus Ws, it is a T minus S, then this value is 0. So this one we can write, it is a T minus S. So expectation of Wt minus Ws square is equal to T minus S. You substituting this all values in this equation. This is my equation number 1. These 3 values is substituting here. So what will get our 3 values? This expectation Ws square, we know it is a Ws square plus this value, it is 0. We received this value 0, and plus this is T minus S, and already minus T is available. Minus T is there, that we written here. Then this value is gone. So it is a Ws square minus S. So it is same as the Wt square minus T we expected, it is a Ws square minus S. So it is a current value. So future we expected it is same as a current value. So this we can say it is a Martingale. So Wt square minus T is a stochastic process. We solved like that, and Wt we substituted Ws plus Wt minus Ws. It is a increments. It is following normal distribution of 0 and T minus S. We substituted these all values. It is like a plus b all square, and instead expectation of Ws square is the initial value. We know the Ws square only. This one expectation value Wt minus Ws is 0, and this total value is 0, and it is like a variance plus expectation of S all square. So we solved, we got T minus S. Whether this Wt square is super martingale or martingale, in this case because Wt square is minus of T. So some values reduced from Wt square for making martingale. So Wt square, like we can say Wt square is a sub-martingale. It will be greater than the current value. That is the reason we reduced some value. We minus from the Wt square some value, we minus from the Wt square. So we can say it is a Wt square is a sub-martingale. This one we can say it is a sub-martingale. Because of some positive drift, it is increased, Wt square value is increased. So we reduced some value, then only it is become martingale. So this is just one problem we solved. We understood some basic of the martingale. So thank you for watching my video. Please subscribe my channel, Braille Institute. Thank you.